give the output signals S and T for the circuit shown below if the input signals P, Q, and R are as specified. Note that this is not the circuit for a full adder. Okay, so what is the half adder? The half adder is a circuit. So in each of these boxes is a circuit, and there are two outputs to the circuit, the sum and the carry. So it's a little backwards here because on the top here it says sum and the bottom is carry here, whereas the outputs of these half adders have the carry on the top and the sum on the bottom. I'm assuming that S means the sum and C means the carry. That would make the most sense here. Okay, so let's start with part A. P is 1, Q is 1, and R is 1. So that means this is 1, Q is 1, and R is 1. So let's start by figuring out what the outputs are for this first half adder. The inputs of this half adder are both 1. And using this input-output table, we can see that when P and Q are both 1, the carry is 1, which means C1 is 1, and the sum is 0. Put another way, 1 plus 1 in binary notation is 1, 0. Now for half adder number 2, the inputs are 0 and 1, and according to this input-output table, the outputs are 0 and 1. The carry is 0, and T here is 1, which corresponds to the sum. Next, I have S, which is the output of this AND gate. The inputs of this AND gate are 1 and 0, so the output signal is going to be 0. So here's my solution for part A. For part B, P is 0, Q is 1, and R is 0. So for the first half adder, we have inputs 0 and 1. And according to this input-output table, when one of my inputs is 1 and the other input is 0, the carry is 0 and the sum is 1. So my carry is 0 and my sum is 1. And that makes sense because 0 plus 1 is the number 1, which is represented as 0, 1 in binary notation. For half adder number 2, the inputs are 1 and 0. And just like for half adder number 1, the carry is going to be 0 and the sum is going to be 1. The inputs of this AND are both 0, which means S is 0. So here's my answer for part B. Part C, P equals 1, Q equals 0, and R equals 1. For half adder number 1, we have 1 plus 0, which gives me 0 as my carry and 1 as the sum. For half adder number 2, my inputs are both 1, which means my carry is 1 and my sum is 0. And the inputs of this AND gate are 0 and 1, which means S is 0. So here's my answer for part C. Thanks everyone, and I'll see you in the next video.